Hi everyone, and welcome to another part of our data analytics technique series. So today we'll be talking about techniques to understand your data as a data expert. In our previous video, we spoke about this to an extent, but we just wanted to dive deeper into it because we know this is a very important aspect as a data analyst or a data scientist. So this is just like trying to set the foundation, the question of why do I even need to understand the data before I start the analysis. So think about whatever you're going to be doing as a data analysis. As a data analyst, you are working with the data, and the length at which you understand the data would give you so much flexibility on how much you can do with the data. So one thing we call data analysts is we call them data investigators. So you're trying to find something, you're trying to show something. So and if you're trying to find something, you need to understand that resource you're using, and the resource you're using here is your data. So after understanding what the stakeholder wants, which we spoke about in our previous video, we kind of spoke about how you can probe for that to know what the stakeholder wants. You understand what the overarching goal is. That is what do we want to do with this data? So the next step for you is to understand the data yourself. So data comprehension or understanding your data helps with better data cleaning. So it makes you know, oh, these are the things that are not required, these are the things that need to be transformed, and basically data exploration in general. Another thing is that it helps to provide recommendation to your stakeholder. So from you understanding the data, you understanding what the stakeholder wants, you can circle back to the stakeholder and say, it looks like we don't have XYZ variable that is going to help us solve this problem or show this result because of the data that we have available. Also, you could understand that even though we have these variables available to help us understand this problem, it looks as though there's something wrong with the data collection process, or it looks as though the data is not reliable. So also it helps you understand the strength and limitation of the data. So from the onset, you know how much or what's the extent to which the data can be generalized. Um, are we certain that this result is going to be reliable, even though you get a result that is showing you a certain direction? The goal of a data analyst is not just to show results. The goal of a data analyst is to be able to show reliable results. And that is where a lot of people are missing it out. It also helps you to know if the analysis is like doable. So that's something also that we need to pay attention to, or why we also need to understand the data. This is just to refresh our memory. So what are the types of data that we have available? So we have quantitative, qualitative, mixed method. So you need to know what type of data is this. So for you to understand your data well, so if it's quantitative, that is you have more questions that have options. If it's qualitative, if you have questions that are more open-ended, or there are they are mixed, as open-ended and closed-ended question. So that's mixed method. So you need to first of all realize that if someone is giving you qualitative data, and that means they require you to perform a qualitative analysis, and peradventure you have not performed any qualitative analysis before. I mean, it's something that you could basically tell them, oh, this is not my expertise, and this is something I can't do. And you could walk away from the project, or you could use that as a learning curve to get better. Other things you need to know is a code book available. We didn't speak about this extensively in the previous video, but if a code book is not available, one of the things you need to do for yourself is you could create a code book for yourself as a data analyst. Even when a code book is available, it's advisable that you create a sub code book, because most times in data analysis, you would have variables that you don't require in your data, and that's the standard like data that we have. Like we have So most times we have data that you sort of don't require for the analysis. So let's say you have a code book with about, let's say, 20 variables, and you are just going to use about, let's say, 5 or 10 from the larger code book, it might be difficult to be going through everything. So one of the things you can do, either the code book is available or not, um, try to create a subcode book first. So peradventure the code book is available. So look at it. What are the variables that I require? Let's say age, sex, income. You try to look at, oh, this is how they define it. This is what it means. And you can create a sub code book for yourself. And if the code book is available, you can look at the variables that you think you require and intuitively create like a code book to define, such that when you are doing your analysis, you can always refer to that code book for having a context, because most times in your analysis, what you would show would just be like a small naming of the variable. Say, for example, you have something like household income. You would not write household income just like that in your analysis. When we do practical projects, we are going to show you what we mean by this, why it's better to have a code book for yourself, even though a code book is available. Moving on, so you need to ask yourself, so what's the number of data required for the analysis? Sometimes in a data analysis project, you might require more than one data to work on the project. So, and this is what happens more often than not. So you would have to like combine one or more data, or find a way the data are sort of aligned together. Either you join them or different ways. So there are different ways to go about this. You join them based on rows, you join them based on column, or you don't even join those data. You just analyze them separately and intuitively connect them during your interpretation. So another thing you need to know, what's the number of column required for the analysis. So when we say column, we are also talking about variables. So we are, most of the terms that we are using here, we are having an assumption that you've watched the previous videos. That's why we are not going in depth into some of those terms here. So understanding, you also need to know if understanding if the data can answer the proposed question. That is the question the stakeholder wants you to answer. You need to also know what is the sample size. So the sample size can be known by the number of columns. So we know that column is, so this is the direction of a column, this direction of a column. So what is sample size? Ideally, you want a larger sample size. The question you might have is, how large should a sample size be? Sometimes um you don't have like control over that if the data is already given to you, but just so that the larger sample size you have, the better it is. And you can also make a data like have an abridged version. What I mean is you have a smaller sample from the original sample. Let's say your laptop is doesn't have a lot of machine to do things, so you can have a smaller sample such that you use a smaller sample for your analysis. When you get things done, then you can do the analysis again with the larger sample. Or if you're just practicing a project, you can do it with the smaller sample. The issue with that is if you are using a point and click tool. Remember, we spoke about point and click tools being Excel, Power BI, and you have to change your project or do that over again. That means you have to start again. But if you're using a coding tool, all you just have to do is just change one or two lines of your code and you get the same result. And that is why if you really want to like go really far in your data analysis journey, let's say you want to we work for bigger corporations, undeniably, you still have to learn the coding tools, but you will be good enough for understanding projects even without the coding tool. So I would say like take one step at a time, understand how data analysis work, and if you feel like you really want to go into the coding tools, then it's easier for you because then you're not learning coding and you're not learning how data analysis work. So you also need to ask yourself how much of cleaning is required. So for you to know how much of cleaning is required, we spoke about this to an extent in a previous video. You need to know, is the sentence cases alike? Is the content aligning with the name of the variable and different things like that? So you know better data cleaning process as you work on projects, and that is how it works when it comes to data analysis. So let's show us a practical example from a data that we have here. So today's section, it's not going to be long. We have so this is a variable, is a variable, and this aligns with a column. So first of all, before we analyze this data, imagine we're given a data analysis and we do not even have a stakeholder to tell us what the question is. So from seeing this data, we know that there are some missing levels here. So some things are missing here. The phone number is missing. But when you think about analysis intuitively, so there are some things that in a way necessarily would not make sense for analysis. And that is how a data analyst or a data expert will think about projects. So anytime you see, and this is something that you need to you figure out, right? Anytime you see a text data, and I'm going to say this like very clear. Anytime you see a text data, that is a data that sounds categorical. I won't say categorical data right now because it's not categorical data. It's very important. Anytime you see a text data, that's a data that is in text, not number, like the data is in text. Anytime you see text data, most times, not all the time, most times when you see a text data and they are unique in everything. So for example, this customer name, if you look at all the data, you just find that we have this person, Jamai, then Christopher, Beryl, Shireen. We have different persons. Assuming we have Aliciana a lot, and we have this Feral Faber a lot, it might make sense. But anytime you see a text data that is just unique person name for everybody, you most likely don't need it for your analysis. So you most likely don't need for now because in data analysis, we want to quantify things. So if something only appear one time, imagine we have 10,000 record and we have 10,000 different customers. Like, what do we want to show? We want to show we have 10,000 different customers. So you need to see that doesn't make sense. So we can't, in a way, we might, most likely won't do anything with this column here. So that's like give you an intuition. So this customer ID is just almost another thing for the customer name. So this customer ID here sometimes is, let's say you have another data set and we want to like match these two data sets together. The other data set might also have something like customer ID where we'll be able to match them on this column. So, but if you're not matching a data, most likely customer ID is still going to be dropped also. So for this email too, we figure out that, so this is how you think when you think about what variables would be required, or this is how you understand your data, what variables would be required from the analysis. So imagine this is all your stakeholders saying to you and they ask you to do analysis. But however, this is not a full data. I just had to truncate a part of the data set. So looking at this also, this is email, thinking about this because this is also unique. We have different emails from different persons. Most likely we don't need this for analysis also. Looking at this also, this is also phone number. This is not a text data. This is a number, but technically we'll take this as a text because this already has brackets. It's a phone number. So generally, most times as data analysts, we don't analyze phone numbers. So that's something that you need to know. So this rule might work for an address here because address is also a text data. But if you are, let's say, a spatial analyst, so a spatial analyst or you're a data analyst who knows how to do mapping, or so that's like how you do mapping. Part of your learning, so some data analyst knows how to like try to do mapping, and it's something that you could learn um as you go in your career, right? So then they can use this address. But if your stakeholder doesn't want you to do any map, then most likely you are not going to need this address. In fact, like even those who do mapping necessarily don't need the address. There's something else they need. They need the geocode. They need the geometry that shows the point of a location. So cities, now this city starts to make sense because you notice that in this city we have Los Angeles twice. So if let's say we have San Antonio, we have Patterson, we have Scranton, let's assume in this city, right, we only have different cities and we don't have like maybe some cities that were repeated, then we might not need to like do any analysis for the city. But paraventure, we have something whereby this data is 10,000 records. So we have Los Angeles about 20 times, we have Scranton about 10 times. So you might not know the amount of times they appear, but just by skimming and scanning the data set of that particular column, you try to see, oh, do I see any variable or do I see any of these levels here that appear more than once or at least maybe 4 or 5 times if you could count them randomly, then you might say, okay, I might need it for my analysis. So if I were you, during trying to explain the data, I first of all create a copy of this data. You don't start to delete your data before you like make sure you have a backup copy. What I would do is I'll delete this column, delete this column, delete this column, delete this column, delete this column. This one I might keep it. But if I notice that they all have unique things, then you I would like probably also remove it. So one of the things we do as data analysts is that we kind of do top 10, top 5, or top 20. Top 20 is not very common. Most of the things what you see is top 5. And when we start with analysis, we would show us why we would do top 10. Imagine we do this city and we have like 30 different cities here and you want to show a graph or you want to show a bar or a graph or something of the number of cities that we have and counts, let's say we have San Antonio 10, Los Angeles 15, and we have 30 different cities. If you show that in a graph, that's going to look very messy. So that is why sometimes we show, oh, let's show the top 10, let's show the top 5. But when we talk about like the type of analysis to run for each variables and the type of analysis not to run, we are going to talk about the do's and don'ts. So we'll let you know. So thinking about this, right? So this is country. So this country column here makes sense because we see United States appearing a lot of times. We see Ireland also appearing few times. So if you want to know, oh, how many of our purchase is in Ireland or United States with other variables, then this country data is a good data. So this postcode here, you will notice that we need a couple of cleaning for it because some of them are not aligning. Look at this. We have 78205. This is how a postcode should look like. Postcode is also like zip code. It depends on the country you reside. Then you see D6W. So this shows you, oh, this is data cleaning. So you see, the more you look at data, the more you say, okay, this is not necessarily, this is something we don't need. So moving on, let's show us another example. So this is the same data set. So if you notice, age stops here, age also continues here. So imagine this is just on a straight line. So for the sake of clarity, that was why we just kind of had to break this down. So here we have yes, no attrition. So then you need to know what does attrition mean. So even though you don't know what attrition means, you could quickly look at Google. I need to know in what context are they going to be talking about attrition. If you start to look at all the columns, you see employee number, you see employee count, you notice that most likely attrition means when people leave something. So it means like when a worker leaves an organization, so is the worker still there? So you begin to get the context of what the project of what the project is from looking at it. So this is attrition, yes and no. This looks like a variable that we'll use. So travel, business travel, rarely, frequently. So if you see this is appearing multiple times, this is the variable that I'll use. You see also age, this is the variable that I'll use. The same thing also with these, the same thing also with these. Life service, life is talking about the field. This is the variable that is useful. Employee number, staff 12317. I'm not sure this is a variable that I use because look at it, this is unique. It keeps giving, it's more like the employee ID. So you can drop this column, like when you're looking at your data, employee number is still the same thing. You drop this male and female gender. Looks okay. Job role, this looks okay. marital status, this looks okay. Why I'm saying it's okay is because you have repetitions. Marital status, single, married, you see it appearing a couple of times. Yeah, this looks okay. Um, over over time, yes, no, yes, no, this looks okay. Over 18, if you look that, so the full data set here, I have access to the full data set. Everything is Y, and I want to guess Y means yes, means everybody's over 18. So if everything is the same, then there's no point in analyzing, right? So you would drop this. So because in data, you see, we are trying to quantify, we are trying to see the difference, what is higher, what is lower. So training time last year, 0, 3, 2, 5. This looks like, okay, maybe we can add it. Then you could still leave this age. Yeah, so you notice that we have age here as a numerical variable. We have age here as a categorical data. So remember, numerical data is you have something that is numeric in the numbers. Categorical data is something that is in categories, like you say 35 to 41. And this is one of the things we spoke about when you can transform a numerical data to a categorical data. But most likely you can't. It's very rare. You can also transform a categorical data to a numerical data, but it's rare. But it's oftentimes you can transform a numerical data to a categorical data. So what you just have to do is, so whatever metric we want to use, so you just do anyone between 25 to 34. Instead of writing their age, you just write 25 to 34 in front, but you won't do this manually. You will do them based on your software. So going forward, we have CF current employee. So you need to actually still go that what does CF current employee means? Daily rates. This is most likely the salary they collect. Distance from home. Yeah, this looks okay. So we want to know, okay, how far they are from their home. This is the education, employee count. This looks like one all true. Then you drop this. Employee satisfaction. You notice that the number is varying. Then you leave it. Hourly rates, this is okay. Job involvement level, most likely this is like how they're involved with the job level, 1, 2, 3, job satisfaction, monthly income, monthly rate, number company worked, percent salary high. Now, so what we are doing here is we've not started analysis. So from looking at this data, then you start to think about how are these things connected together? What are the variables I can connect to one another? What variables do I think is more important? You can even create something like a different data for yourself where you say important, less important, the ones that you're still thinking about, or you could even highlight them and say, oh, this is looks very good. For example, some of the variables here are more important than one another. For example, this attrition is more important. Maybe like sex is more important. Something like let's say hourly rate might not be important because we have hourly rate and daily rate. So you can just choose between one of the two and say, oh, I want to go for hourly rate, or you just want to go for monthly rate or monthly income. So because it's still like the same, all right? So that's how you think as a data expert when you see a data. So this is the last one we showed for now. So this is ID. So you notice that ID is also unique. Like we said, if you're not merging to data set, you don't need an ID for analysis. So drop it. Marital status, we necessarily, yeah, if you don't have a code book, this is MS. So we can intuitively say M will be married, S will be single. So even though your stakeholder did not give you a code book, don't be a pain in the ass to say, no, you must give me a code book when you can, from intuition, get to know what they mean with the data. And that is also why you yourself as a data analyst, when you are naming your variables, you need to name them based on something that will be easier for someone else who doesn't even understand the data to have a grasp of what your data is talking about. So you don't want to do something like G and F. Yeah, and somebody's like, what does G mean for marital status? So gender, you have F, and we know this is going to be female, male. For income, we have the amount here. So the reason, because we have this dollar, this is a numerical variable, but because we have this comma, we have this dollar sign, this has made this variable a text. So that is why we need to remove this for analysis, except during the imputation of this data, there was something that they did, or most likely in Excel, that would still classify this as a numerical data. So there's like an advanced thing you would do. But if you are given a raw data, or you transform this data to another programming language, let's say Python or any other language, and this is how your data is given to you, and you have something like the dollar sign, the comma, then you have to ensure you remove them, but not like you remove them manually. You would remove them in an automated way. Children, you say, okay, this is the number of children, batch education, bachelor's, partial, college. So occupation, homeowner, yes, no, cars, 0, 1, 2, 3, commuting distance, 0 to 1 miles. This is a categorical data. So you get to see region, Euro, Pacific, age, buy, purchase, yes or no. So from this, you can, from looking at your data, you can begin to see what variable here do we think would be the major variable of interest. From thinking about this, we might think, oh, probably this is like a business data. They want to know those who are more likely to purchase their bike. And you say, oh, okay, maybe this is a major variable. So that means everything has to be connecting to this bike purchase. Like, because what else would it be? Like, why would they bring this bike purchase here? Looking at the previous data we looked at, you saw that there was a question on attrition, and there was a question on like different things about the employee due rates. So most likely what they are thinking about is, why would somebody leave an organization and why would somebody stay? So even if your stakeholder is not thinking about their data in that way, yourself, when you look at the data, you can give them likely questions that they can ask just from the data, and you can basically say, okay, these are the type of analysis that are very important, and these are the other ones that we can add, or you might want to supplement if you really care about. And you try to have a focus such that you are not analyzing income with children. It makes sense to do that, but we know that the central aim is to look at everything in relations to buy purchase. So that's why you want to focus on the major things first before you do the minor things. Um, Conclusion, like we always say, make sure you read more and you familiarize yourself with this explanation. Um, there's a lot that you're learning right now, so it's just best you take a break, watch the videos again, go back to previous videos, the concept you've forgotten, get to learn them more and more. So remember, this is a journey. So 1,000 miles start with a step, and you just have to be curious and set goals and remember that you can do this. We'd love if you follow us on our social media pages on LinkedIn, on Twitter and Instagram. Thank you so much. So stay tuned to the next videos.